In this video, I will show you an example of a quadratic equation that has complex solutions. And here, the problem is asking us to use any method. I'm going to show you two different methods. First of all, it's worth noting that when quadratic equation has complex solution, most likely you won't be able to factor it. So we're not even going to try to factor this quadratic trinomial, but I'm going to use the quadratic formula and completing the square process. So in order for me to use quadratic formula, I'm going to isolate this quadratic trinomial on one side and set it equal to 0. Now, after I identify my coefficient a 5, coefficient b -6, and coefficient c, I'm going to plug in those numbers into the quadratic formula. So I have -6 plus minus square root -6 squared minus 4 times 5 times 3. And we divide it by 2 times 5, so the answer is 6 plus minus square root. 6 squared is 36, and we have 36 minus 60, which is -24. So we have 6 plus minus square root of -24 over 10. Now notice that if we don't know complex numbers, we would have to say here that there are no real solutions because we cannot find square root of -4. However, since we at this point do know complex numbers, we are not slowing down by this presence of negative number inside of the radical. We just kind of take care of it by adding or using an imaginary unit. And now square root of 24 can be simplified a little bit further, so it's 6 times 4, meaning it's 6 plus 2 square root of 6i over 10. And this can be reduced by 2, so it's 3 plus minus square root of 6i over 5. So the two complex solutions of this equation are 3/5 plus square root of 6 over 5i and 3/5 minus square root of 6 over 5i. Now, alternatively, we could have solved this equation by completing the square. And to complete the square, I'm going to isolate the quadratic expression that contains the square and the term with power 1 on one side, and we need to make this leading coefficient 1, so I'm going to divide everything by 5. And to complete the square, I have to add half of 6/5 squared. And I'm going to add it to both sides because we're solving the equation here. Now, the left-hand side becomes y minus 3/5 squared, and the right-hand side has to be simplified. So what do we have on the right-hand side? We have -3/5 plus 9/25, so which is -15 over 25 plus 9, so it's -6 over 25. Now, next we use the square root property. Let me again remind you what the square root property is. It says that when something is squared equals to a number, some non-negative number, then what's squared is either plus or minus square root of that number. And actually it doesn't have to be non-negative now because we do know complex numbers. So applying the square root property here gives us the following statement: y minus 3/5 is equal to plus or minus square root of -6 over 25. And again, if we don't know complex numbers, at this point we would have to say that there are no real solutions. But since we do know what complex numbers, we interpret this square root of a negative number as square root of 6 over 25 times I. And that can be further simplified as square root of 6 over 5i. And therefore we have two equations now, which we solve by adding 3/5 to both sides. So after I add 3/5 to both sides, I get 3/5 plus minus square root of 6 over 5i, and that means that we actually have two solutions. One is 3/5 minus square root of 6 over 5i, and the other one is 3/5 plus square root of 6 over 5i. And you can see that we obtain exactly the same solutions as before. So it doesn't matter which method you use, you will get the same answer. However, when you're dealing with complex solutions, it's probably the most efficient way is to use quadratic formula.